Okay, hey. So we finished up. Whoa, bumping the tripod already. Okay, so we finished up the controller and getting into the sound board problem. So basically, you can see I've got the sound test running. We have no sound. So plan of attack on this. So a couple things here. Let me get my voltmeter. The Joust schematics actually have a really nice audio troubleshooting section. So kind of like your basics. So the basics are, just test for power. So I think the power is okay. So just kind of run you through. I've got my meter set on volts DC. So this power supply, you only need powered in negative 12 and positive 12. If you're using a switching power supply, you need to use the 5 volts. But this board right here that has a 7805 5 volt power regulator. So this will generate its own 5 volts, not 5 watts. Well, we want wattage, but first things first, power. So just kind of checking the power here. Now, over on the schematic, the troubleshooting guide, it is talking about your test points. It has all your test points. So test point 1, you're looking for 12 volts. I don't know if you guys can see that. So we got 10.51 volts. That's a little bit low out of this bridge rectifier, but that should be enough to get us our sound. I'm not so worried about that right at the moment. Okay, so... And then you are looking for your 5 volts between, from your 5 volt regulator. So across that guy, well, if I get it, the leads the right way, we have 5 volts, 5.07 volts. That looks pretty good. We can kind of go through and I think test some of the chips here. Oh yeah, these are weirdo chips, the power. Let's see. I'll just run through here, check some of these. 274, that might be, I'm not sure if that's the DAC. Some of these are a little bit different from each other. 5 volts, 5 volts, 5 volts. CMOS is on the other side, 5 volts, 5 volts, 5 volts. Okay. Okay, so I do think the voltage is okay. We can check some of the capacitors. That's supposed to be 12. You got your negative 12 unregulated, maybe? Negative 12 unregulated, I think. So I'm pretty confident that we have power everywhere. There's 5 volts on that cap. One of these emitters is supposed to have 5 volts. Just noticed the, yep, got 5 volts on that transistor emitter. Not sure about which leg or what this guy is doing. My printer's broken. I like to have the schematic down here, so I'm going to be bouncing back and forth. But, okay, so we have power. So let's check for our binary sound signals in on our sound in cable. So these are just wired straight through. Both pin 1 start here, like on the side facing me. Pin 1, 2, 3. Check my cable. Kind of good to go there. So as the sound test cycle, you're looking for activity on the scope. I know it's way over there, but you can see it. Okay, it's doing its thing. There's bit 1, 2, 3, 4, well, it was just a bad connection. 5, we've got toggle in action there. 5, 6. We have action. We have activity. And 7. Oh, 7 doesn't appear to be doing anything. Let me check 7 down here at the other one. Have to check the print. I'm not sure if this one is supposed to have activity or not. I think it should. So, yeah, there's no activity there. He's stuck high. So, okay. Irregardless, here's the plan. I have a cap kit. So, we're going to replace all the capacitors. I'm going to replace the 40-pin socket. I'm going to replace this, not this one, the EEPROM socket. I think it's 24-pin socket. And then we will go from there. And I also know we have clock signal. That's another thing you want to check out. Let's see. Now the clock signal looks like, oh, there it is. So we have clock signal. I checked it before we started filming. Okay. And we'll go back to the troubleshooting guide together. Okay, so I'm going to cut off. I'm going to check this bit 7. And they feed down through these capacitor and resistors into one of these ICs. So I'm going to check that just to make sure that's not goofy. Okay, so here is the other, sorry, I got to sneeze. Okay, so the diagnostic button, if I push the diagnostic button, we should get a tone. Well, I was getting a tone before. I'm not sure why I'm not getting a tone now. Anyway, that's kind of weird. I did get diagnostic tone just a minute ago. My speaker's up. Maybe I have to be in game mode, or that's got to be stopped. Weird. I don't know why I all of a sudden don't have those. So before it was just a hum. The diagnostic tone was just a hum, and I don't think it should be a hum. I don't know what it should be, but it should not be just a hum. So, see if I can get my finger on that amp. I was getting... Yeah, what is the deal now? I was getting sound through my amp. Like when I touch on the output leg, it was humming just a minute ago. I was getting some static and whatnot. Let's get out of this mode. Maybe. Oh, now it's not wanting to exit out. That's weird. I am stuck in sound mode. Interesting. Let's, I'm going to reset the board. Boom. I'm going to reset the board. Let's let this thing... Okay. Yeah, I am not getting any sound now. My speaker's in my test module here. That is super weird. That is super weird. So maybe we just had some failure. And I do know when it was in diagnostic mode with the hum, I was pushing around on the CPU and it was coming and going. So what I'm going to do, I'm going to cut off. I'm going to verify this audio RAM. It's a 2732. I'm going to dump him and make sure he's okay. I think I have a tester for this 6808 CPU, but I think I'm going to test these off camera. I'm going to get my cap kit going. I'm going to change out all of these. I might film a little bit of that, but that's the next plan of attack. I just want to get rid of any problems with the capacitors and sockets and EEPROM, since we know that the voltage is good. So let's start there, start cleaning this guy up and giving him a good refresh. Okay, so I decided today I'm gonna, instead of using my gun on the back of that and desoldering, since they have the single swipe sockets, I already threw them in the trash, let me show you. Since they already have the crappy single wipe sockets, I decided just to pluck these. It takes a little bit more time, but you're pretty much guaranteed not to mess up your board. So it's going to come in here. It's going to come in here and just start plucking them out. And you want to just kind of wait until the solder, until that pin moves freely, just pull it out. And then we'll go in with the solder gun on the top side and just clean up the hole. I don't know if it actually takes longer. It probably takes about the same amount of time. If you get good with both methods, it could be just as like this one here's got there's a power trace. There's a big thick. It's going to soak up the heat, boost that heat a little bit on the gun. This is only a 20 watt 220 solder gun. I love it though. I love this little thing. Oh, there she goes. Whoop. Just had to get that one a little bit more hot. Can you see? Yeah, you guys can see okay. I probably won't film all of this. Maybe I'll just film a little bit of each. Yeah, only 2 sockets, so that's cool. Yeah, I like this way. You can actually pull traces, like if that pin is not totally loose in there and you pull it prematurely, you will pull up the trace. So if you do it like this, just take your time, because it'll be better than the time you have repairing stuff. All right, I'm gonna come down to this guy. We'll do that back row, then we'll spin the board. See, I mean, you get them like this one's got a big ground plane. They get loose, but you want to wait until all that solder is molten. Got a quick heat button on my gun. It says you shouldn't use it, when you're soldering stuff, but sometimes I do. If I'm trying to get heat in a situation like this, I'll go ahead and use the fast heat function on my gun. See, like that guy, he is, and I did put the flux too. There we go. I did put a line of flux on there. Yep, just get that solder gun right on the pad and they come right off.
In all seriousness though, this boss out of pretty much every Zelda boss in the history of Zelda bosses is probably one of the worst designs for an abyssal Leviathan that I've ever seen. And yes, its design looks like something out of Monsters Incorporated.
Yeah, I'm watching Zelda videos with, what was it, Tears of the Kingdom? Yeah, I'm watching Tears of the Kingdom videos. My Switch is at home. The only reason I have a Switch was to play Breath of the Wild. And I got through most of it. And it's, I don't know. I mean, if you bash Zelda, you're going to get, it's like, you're going to get freaking attacked by everybody. But it was an okay game at best. The whole weapon degradation mechanic just freaking ruined it. Fucking Nintendo, man. They used to be awesome, and now they just making their money off of a... I don't know what to say about Nintendo anymore. But when I get home, I definitely want to play Breath of the Wild. I've got the bug. Yeah, it's just some fuzzy... Ooh, there's just some fuzziness going on here. Yep. I swear this camera used to focus and be a lot better, but whatever. I'm going to get a camcorder soon. I'm going to get a different camcorder or camera. I don't know if it'll be a camcorder, but it'll be something that focuses. Yeah, I don't know what happened to this phone. The Galaxy 21, was it S23? Man, it was awesome at some point in time, taking videos. Now it seems like when I focus in, it's not so great. All right, let's get the heat going in this guy. I'm not sure, but do with that information what you will. Who knows? Maybe Tantalus wasn't always an abyssal sea monster, but was cursed into that core long ago as a punishment. Yeah, just the end power pin. Yep, you don't want to pull it until she's completely free. You will pull up the trace. It's not a absolute safe way. You still have to be cautious. They're also one of the only monsters in the entire franchise that has made an appearance in every Zelda game, I think. I'm not sure Yeah, I'm excited, man. I replaced that pump in my gun and it works really good. And before, when it had the hole in the diaphragm, it wouldn't even clean the top, clean the through holes, even with like fresh solder or whatever. So I'm kind of looking forward to this. Yeah, they just come right out. The pad's not all that big, but if you get I'm using a hoof or a wedge tip. You get the hoof or the flat part up on the pin, get the heat going in there, then the tip down on the pad. Kind of heat them up two different ways. It heats that solder up two different ways. Yeah, it heats that pin up, and then it heats the solder and the through hole up. I mean, just look at this thing. It's shiny, it's kind of creepy, it's got 6 arms and wee little legs. I mean, what's not to love? As its name insinuates, and in conjunction Come on, baby. With the system within which it is located, Galactos is in fact ancient, and given that it was an automaton that was ultimately tasked with guarding the chamber of the flame. I think this is a ground pin, maybe. Robots was the one to create both the dungeon itself and Galactos. That being said, Galactos might have actually... Yep, you just have to be patient. Yeah, my Weller at home, I'm excited to get back to my Weller. That thing doesn't lack any heat. Okay, where are we? Let's get you... Okay, I think we're going to cut there. We'll come back when we're ready to clean the holes. Okay. So got all the pins plucked out. So let's get the gun going. Let me get my cable, power wire up here. Let's get these holes cleaned out. We'll do a few of these. Then we'll get those capacitors out and get this board cleaned up. All right, let's go. I might have to use my bigger wire. That's actually okay. My God, it works so much better. Yep. It's got some crud down in it still. Yep, just like that. See if I can't get that. It's not gonna. I can see it's like focused right there, but it keeps jumping out. I hate that.
I'd like to start off by saying that there are many different theories about how demise came from Laurel and stuff like that, and it's all really good stuff.
Right there.
As far as I can tell, it comes down to
Why won't it stay?
said to have emerged from a fissure or crack within the earth, and his master sword, aka
It's not gonna do it.
has an inverted trifle.
Anyway, we'll do a few more holes, and you guys get the point. Yeah, those look nice and clean. I'll show you guys better when I take the camera out of the tripod. Okay, so I'm going to pause there, and I'll show you the work after. Okay, so we're back. We got the pins out. We got all the through holes clean for the 6809. I think it's 6809. 6802, sorry. Yep, those look good. No damage. No damage, nice and clean. The back side. Okay, so let's get started on this capacitor. I got this on these capacitors. So I've got a rebuild kit from Arcade Parts and Repair. So this is the D8224 soundboard. And I kind of got the caps out here, just kind of looking. We're going to do some of these together. I go, you know, I think it just depends the day how I do these. But I think today I kind of want to do them like the pins. I think I want to snip those legs, heat them up, and pluck them. Let me get my side cutters. In case my voice was turned away, I think I want to snip these and try to heat them up with the solder gun and pull out the legs, then clean out the holes with the solder gun. Yeah, these capacitors look crappy. They really do. I'll show you some of the other bad ones. Let me see if we can't. I don't know. Let's see how straight that. Yeah, they're straight on the bottom. But the problem with doing it this way, there's so much area of heat plane. I don't know if this will work or not. We're gonna try. We are gonna try. I don't know if it's gonna work or not. Might be better just to desolder them from the back. The solder gun gives me a lot more heat, but I wanted to try a different way. Yeah, there's so much. See all that metal? The heat's just sucking it. It's just sucking all that heat out. It would take my good. I think that would take my good solder gun at home. Let's get that. Let me get my gun over here. We got a 0.1 mm tip in here, which I think might be okay. I might actually have to turn up the heat. Let's see if just got to be patient. There's a lot of material there. Look. Yeah, I think that worked okay. Like the ones where there's just a pad, that's not a big deal. Those guys will clean right up. Oh, I just desoldered a diode. Oops. Yeah, it was off to a good start, right? Pay attention, man. Let's solder that guy back before I forget what's up with him. Oops. Yeah, pay attention when you're doing this stuff. I have no excuse. And let's get, man, it's going to be, Probably not great to try to resolder.
Are not new enemies to the franchise. Far from it, actually. With their first appearance starting with the first game and stretching to being included in 12 of the games in total. In each appearance, Witch
Yep.
are always an
My poor little solder gun don't like all that surface area. But we'll get some heat in it and it will be okay. Don't need any cold solder. There we go. There we go. Okay. Let's see. Get this gun back over here on the right parts this time. Come on, man, you can do it. Yep, nice and clean. I do have a bigger tip, and I don't know, let's see. I may consider putting it on. We're turning up the heat a little bit. Actually, let's see if I can heat that up and pull that guy out. Yeah, if I had my bigger solder gun, my Weller would be awesome. I'm going to cut that leg down a little. Make sure it don't get stuck in my gun.
Am I right? Anyway, that's where the Garuda swordswomen as mini bosses come in. There's 3 of them in the game, each of which are guarding one.
Yeah, I may throw my bigger tip in on this. Those legs are just a little bigger. Pretty tight for the 1-1 or the 1-0 mm. May have to turn some of these up too. That's okay. Yeah. A lot of heat. Yep, I mean, it's not, it's hot, but, ooh, yeah, it's getting hot. It's just going to take a minute. Gotta be patient.
Next up is the fun stuff, the bosses of Icona. And by fun, I mean scary and depressing. To start, the entire land of Icona is left forgotten and barren waste.
Man.
The mighty kingdom of Icona.
Doesn't even look like it's trying to heat up.
Battles and bloodshed and just general unpleasantness. It's also currently experiencing a very particular plague, one that entails the countless dead soldiers and foreign assassins coming back to life.
That one's okay. See, when it's just a regular pad, it's all good. I'll make sure I don't goof up again. Okay. Just a big via. The first boss you face in Icona is the undead giant who served in Icona's army as its captain, known as Captain Kita, or Kita, who upon being resurrected immediately because he felt the need. Yeah, I didn't suck it when I should have. That's okay, we'll come back. Yep. Still a big plane. There it goes. Alright. I think, well, let me just let me turn this. I'm gonna turn up my gun actually for those big planes. We're gonna give it a good boost. We're gonna go up to about 400 C. See if that will help.
himself, asking Luke to shine the light of justice upon his kingdom with his dying breath. This light of justice comment also seems to imply that even before the plague of the undead was restored upon Icona, injustices had already
Okay.
affected her heart.
It's going to take a long time.
But they're legitimately hard to explain.
Yeah, if I had a
Technically speaking,
better solder gun,
such as the iron knuckle,
or yeah, better solder gun.
those themselves
It
exist as
wouldn't.
linked
Oh, there it goes. She's going.
with the Zelda franchise, and in a land soaked with blood and lined with countless
She is
bodies,
going.
seems to be a gift. But it's the iron knuckle specifically that wants to come in Skull Kid's memories, especially the latter, who are a group of four sisters that once resided inside of the forest of Lavaka at a time, which the Skull Kid lived right outside of.
All right, guys. I think I'm going to cut here. Go ahead and finish this out, so I have some room without the camera in my way.
And the same goes for the iron knuckles in the spirit temple. However, because we're working off of the assumption that
But we'll do this one. I'm going to pull this big one out. I just kind of want you to see how long it takes to heat up. I mean, just to pull that cap leg out. It's a long ass time. But that's a lot. See all that material there? It's like a big heat sink. It's just pulling all that heat away. All that's got to heat up before that cap will come out. Yeah, I don't want to take that tip off of there and lose. Yep. I'm just taking my time. Just taking my time. Okay. So I'm going to cut there. I'm going to get busy on these caps. Okay, let's continue. Let's continue. So I got all the caps out, and it's funny because I fought on camera with the big caps on the big rails, and as soon as I got to the other ones, they all come out super easy. So let's take a look at the work here. Kind of, if you do this, like you want to get things clean. Okay, so we got the new 24-pin socket, the new CPU socket, retinned all of the pads on the part side for the new capacitors, and I took this guy outside and washed it and baked it out in the sun. Yeah, I've had a nice little break here. And let's look at the backside now. The backside's all super nice. There's the ROM socket. Looks good. There's the CPU socket. And then all of the pads are ready for the capacitors. So, and, these stickers, they're always like half on, half off the chip, and I love to wash these boards, but I hate to destroy the stickers. So I put a piece of Scotch tape over them. Some water got up under that one, but you know what? It's still there. That one kind of broke, but there's a piece of Scotch tape, so hopefully it'll be preserved a long time. Okay, so let's get all of our capacitors fit. So with the arcade parts and repair, comes with kind of a hit list. Comes with a hit list, and then it comes with the diagram. And actually, I got this pulled up off camera over on the other computer here. So let's start getting our capacitors in, and let's pay attention to polarity and form factor. Oh, I got delivery. Hang on. I got a delivery guy. Sweaty Cup. How are you? Okay. Oh, Captain Cup. Okay. Mon Ma. Oi. Be careful, okay? All right, guys. Got a package. We won't open this now. So, I am stepping into the world of game consoles here. So this one, I think this is 2 Super Famicoms, or this could be the Super, or what do they call them? Nintendo Family Computers, like the NES and family computers. I don't know. I'm getting ready to leave, so I went on Marketplace. I got some of these dirt cheap, working and not working. So anyway, boy, no wonder I make so many mistakes. I'm always sidetracked. Okay, let's go. Let's go. Okay, so my capacitor rolled out of the way. So I'm keeping a checklist here. Just, yeah, right down here. Okay, so let's go. Let's start with this one here in the back. C25. C25, what are they calling out for? 100 microfarad, 50 volt. There's 1,000, 100 microfarad, 50 volts. Okay, so I'm a big form factor person. I don't like just to throw these in. I like, you can bend them any way. I try to put them where the orientation, the ground orientation and the voltage is up, so the next poor soul can actually read it. And so positive, negative, and yeah, we've been here, done this. I like to get everything kind of, I like nice straight bends, and I like them equally spaced. So it's just an eyeball thing. I was a fabricator for many years, so I'm not bragging on my skills, but I got a pretty good eye. Negative, negative, positive. Okay. So it's sitting on the board here, so I may have to bend those legs a little. Okay. Where's that guy? Negative, positive. Okay, so let's go to the next one. C26. Actually, I'm gonna mark these off as I go. C26, 1025. One of these guys. 1025. Now this one is backwards from the other one, and it's not as big, so you're gonna have more legs sticking out. So what you can do, like this one is smaller than the original. It would have been this guy. So the original board layout, the through holes are designed for the bigger one. Now I know I just talked about keeping things equal, but you want to reduce the risk of the 5-volt line, I think, as much as possible. So I think in this case it's okay to make the 5-volt side a little shorter, because if you have a long 5-volt side, it's easier for things to lay on and short out and all of that. But what we can do, we can line them up. We can align the back edge of that capacitor, so at least one side of them all line up, and it looks kind of good like that. Yep, like that, like so. I don't mind so much the negative side being long. I'm not saying you can't short out the negative side, but I'd rather have more negative showing than positive. So there's this guy. Let's get him in. Wait. He can get bent just a little bit more. So I think you see the point. Let me let's do a couple more, and then I'm gonna cut. Then we're gonna cut. Positive, negative. This one's backwards from the previous one, so be careful. Kind of bend him over. And also that negative gives you, a long negative leg gives you a good place to tap onto your ground points. Okay, so that guy's good. That was C26. Let's do C27. That's the big daddy, the 4,700, 35 volt. I like that they upped some positive, negative. I like to get them on there, see where the bend should be, so I get a nice straight bend. And again, I'll show you here in a second. Yeah, I like to bend them so when it's in, you can see the orientation and the value on the upside. Okay, positive, negative, just like this. Let's see how good. Yeah, we sit in there pretty good. Okay, good, good, good. Okay, that guy's good. Let's work our way around this way. C15, a 470-25. 470-25. Positive, negative, same deal. These guys are a little bit shorter. That's the positive side. So we're going to bend him just a little closer. What I like to do, a close bend for me is like the width of my little pliers here. So I like just to kind of measure like that. Like that's one width. So I come up here and give it the bend. And then I know all my stuff is uniform. And then positive, negative. Let's see where this guy's going to be about here. Just eyeball it. And you'd be surprised how close you can get eyeballing. So there we go. Markings up. Positive, negative. All right, we're just going to let him in there until we get the next one. That was C15. Boop. Yeah, C15. Okay, C14. A 1025. A 1025. Now this guy is backwards, so we're not going to be able to. He's not going to be perfectly in line with his neighbor, but the spacing will be the same. Opposite, which I'm cool with. Positive, negative. And then we're going to come in right about here. Right about there for the other one. Ooh. Yeah, I tried to keep as much of that negative or the positive out. Yeah, I tried to keep as much of the positive hidden, because that's what's going to cause problems if you start dropping stuff and laying stuff across. Okay. All right, there's 5. 4 more to go. Let's work our way up next to the op amp. We have, let me knock that one off. We have C12, 1 microfarad, 100. 1 microfarad, 1 UF, 100. Okay, what's the factor on this one? So he's still nice and tight, so we can give him a straight bend. We can give him a straight bend. You gotta be careful. If you're too close to the body, you don't want to pull the leg out. It will like lever on the capacitor. So if you get your tools too close, just keep that in mind. Positive, negative. I see the positive sign. I hope the silk screen is all okay. But before we solder this, I'm going to grab my other soundboard and we'll just double check. Yep, that guy's nice. Yeah, positive. Yep, positive, negative. Okay. I like actually working on the mounting board, because it has standoffs and it's really nice to work on actually. Okay, that was C14. No, that was C12. 1 microfarad, 100. Okay. Now we're down to C36 or 38. So on the notes for this one, there's actually a note for this one. C38 may be leveled C36 on some applications. Okay, so we're gonna go with the 1 microfarad, 100 there. And he's going to be, yep, just a straight bend again. I like to straighten these out. And just come over and give it a bend. Just barely. Yeah, see how nice? Boom. I hate rolled ends. I hate rolled, like rounded bends, not when they can be straight. All right, marking is up, positive, positive, negative. Uh-oh, we got a tight fitter right there. Uh-oh. We got a tight fitter, something in that hole, just a little bit. So we're gonna, let's just heat him up and push him through. Yep, let's just heat him up and push him through. Aight. There we go. Good, now he's actually tacked in. Just a little bit of stuff in there, that's okay. Okay, that was C38. Okay, two more. C39. Let's see, working our way up. The one capacitor here at the bottom of the CPU, or at the top of the CPU, I should say. C30. 1 microfarad 100. I think that's all that's left. 1 microfarad 100. Kind of dry fit them. Yep, looks kind of good like that. Straighten these guys out. Give him a nice little bend. A happy little bend. Okay, I see the positive, negative. Okay. Yeah, nice. Boom, boom. Okay. Very nice. Let's make him straight. Okay. So let's mark him off. That was C30. Boom, boom. And then C29 is the capacitor here at the top of the EEPROM. No, did I mention, when I cut a couple times ago, I did dump that, and it's fine. The sound EEPROM is fine. The 2732. Yep. See, I got my bend a little bit off on that one. That's no problem. You just bring him in. You want the markings up. Keep the next guy in mind. And yourself. It was a good way to be able to check your work. Negative, positive. Okay. Boom, there we go. So he should fit down in there quite nicely. Yep, perfect. All right. So let's flip him over and we'll tack him in. Actually, sometimes I don't mind tacking them in from the top side. Then when I flip them over, they're kind of where they need to be. Sometimes if you flip them over, you know, they might move on you or whatnot. So let's, yeah, let's just tack them in from this side. Where's my small wire? I already put it over. Okay. Yeah, I'm using a couple different size wires today. This is a 0.4. The better I got at this, the smaller wire I can use. So that's a 0.4. Let's just get in here. We'll just tack one side of each on these. And then when we flip them over, I can straighten the legs and then be really nice solder. Be a nice solder job. All right. Yeah, my nose is running like crazy. It's been hot here. I think it's been like between going in from the into the AC, then out to the heat. I think that's what triggered it. Not sick, not COVID. Okay. I think I heat up a little. There it goes. All right, good. I know it's kind of hard to get to. Sniffle, sniffle. There we go. He's in there good. Excuse me. Sorry about this. Cover your ears. as my ass got tear gassed. Okay, so double check, and I like them straight. So you should take your time. You want your work to look nice. You want your work to look nice. So take your time, line everything up. You know, that's a good thing about tacking them in from this side. You can. Oh, I still think I got that leg kind of weird. There. Okay. Perfect. Let's get the Big Daddy. Yeah, we're just gonna tack them in. If I have to come back and touch them up, we will. You know, it's a good thing about tacking them just like that. You can straighten them out. And when you flip them to finish it off, they're all perfectly aligned. With the 0.4 wire, you're not adding too much, and it looks really nice. All right, get that guy kind of straightened. And here we go with the massive back planes. So let's try to get him in there. Try to get some solder on this guy. Yeah, nice. I'm gonna have to do that one lefty. There we go. Yep. Alright, he's tacked down. Nice and straight. Let's get these last two guys. These are the easy ones. Yep, perfect. I think that's all of them. Did I get that one? Nope, did not get that one. This one here, we'll just do it from the back. It's pretty tight from the part side. All right, so check that out. Nice straight. Form factor's good. Hopefully the orientation is good and they don't blow up on me. Have the long negative side, which is okay. All right, so let's flip him over and we'll get this one that we didn't tack. We'll get him first, which is this one, which is that one. All right, I should probably switch to my bigger wire now, but I think this will solder fine. Get a nice through hole solder. Before I solder the other side, just take a peek. Yep, he's good. This guy right there. Yep, all right. So now that they're all tacked in, you can bend your legs straight and make them look really pretty. They shouldn't move if you tacked them in good. So let's bend all those straight. And don't have to worry about alignment. We're already aligned. Okay, let's do it. All right. And then what we're going to do when we finish these, I see a bunch of cold solder joints, and we're going to go through and reflow. And then we'll do a final clean, and then we'll connect it up and see what we got. I don't know if we'll have any sound back. I was reading through my notes. I already had this on the bench a while back for like preliminary testing, and I did have a couple of notes made about the the ICs after the capacitor resistors of the on the binary system. I guess it'd be on the analog side. I think maybe I had spotted or thought I spotted a stuck bit. But that's okay. I wanted to try to get this stuff out of the way. You know, big ground plane. Get some heat going on this guy. Yep, I can see it flowing down through the hole. Yep. Yeah, you want good solders, but you don't want cold solder. Kind of talked about that before. You gotta have nice hot, you know, especially on these caps that are carrying the 12 volts and the voltage, negative 12, 5, and 12. You want good solder, nice hot, penetrated. Yeah, he said penetrated. You'll know when it gets hot. You'll see the solder start seeping down through the through hole, like that. And then you can. Yep. Let's see. Nice and hot. Whoop. Yeah, some bigger wire probably be okay here, but they got the small going. It's fine. Oh wait, that one came untacked. Let's push him up. All right, I can feel it. All right. Ooh, he's nice and warm. Let's get this side. All right. Actually, here I think I'm going to go with the bigger wire. Come here. I'm going to be feeding solder all day. Yeah, it looks pretty good. Yeah, this is 0.8. Oh, excuse me. Yeah, you'll see the solder start to render around your through hole. I think that looks pretty good. Let me hit this guy again. This one earlier. There we go. This is that little diode that I accidentally desoldered earlier. All right, I think he's good. Push him back down through maybe a little. We'll give it a double check. Yep, they all look pretty good. Not finished soldering though. Okay, missed one. Okay, I'm gonna hit a couple. I'm gonna hit some of these again. I'm seeing a little differently. The board turned. This guy, maybe. And I like them to look factory, but I want them to be heavy duty factory. Yes. Excuse me. Okay, cool. Let's snip those. Let's snip these legs. Kind of check as we go. Let me get my little scrap punch bin. Bam. I like to save these guys. My hand right in the way. Not too bad. Yeah, those are some nice beefy looking solders. I'm okay with that. A little bit heavy duty, that's fine. Okay. So while we're here, look at these guys. Look at these. Look at those. Those look. Yeah, I'm going to reflow all of those. So we've got sound select, volume, speaker, and then the power came off. I mean, look at some of those. And then I noticed also on the test point, yeah, the test point, look at those. Boom, boom, boom. Yeah, we're going to just, now we're just going to go over this board and reflow things that we see and don't like. I think I can use, let me start off with my small wire first on that. All right, let's clean that tip up a little. And then what are those, bridge rectifiers? Nope, that's fuse holders. Okay, so let's do the fuse holder. We'll do the fuse holders, the fuse holder connectors, and then maybe some big pad there. Might take a minute, but this will be worth it to let us know we have good connection. The headers didn't look bad enough to replace. So I'm not going to worry about replacing them yet. Maybe in the future, if a customer wants them replaced, I'll do it. But I'm okay with them the way they are right now. All right. Yeah, that's why I like to kind of clean the boards too. Kind of get some of that surface oxidation off. Then when you go and reflow, you have at least as clean a solder as you can get. Yeah, those don't look too bad. Oh. All right. Yeah. Come on, baby. The small wire is good, but you gotta feed an awful lot of it sometimes. That's okay. You're better in control. Yeah, that guy was kind of cruddy. That's a good thing about reflowing. It will burn some of the nasty crap out of it. The oxidation that's built up, corrosion, electrolysis. We always talk about electrolysis. That's your worst enemy right there. It ain't so much the oxidation, is when voltage runs through here, creates like a barrier coating on the actual pin. So that coating builds up between the solder and the pin, and that coating is not conductive. So, okay, then I think that, okay, power, that, okay, this is volume. Let's hit some of these, boom. Boom, okay. Yeah, I know I'm not super zoomed in. Could probably try to zoom in a little bit on these last ones. Yeah, just freshen that solder up, get a new good fresh bite. Burn some of that crap off and get some new solder in there. Helps with the conductivity. A lot of that oxidation, I think, comes from when they snip the header pin. Like the cross section of that pin is like, it's steel. So that's a lot. You can kind of see down in the center. That's where the blackness starts. All right, there we go. Let's take a look around here a little. Oh. Yeah, let's get these test points. I think I'm gonna get the big wire for that. Let's get. Yeah, these test points right here. It's for 5 volts, and I think you're negative 12 unregulated. So let's reflow those. I mean, those are just test points. Those are just kind of the end of the line. It's like a test tap, but we don't need those falling out or causing any problems. Like when it is a test point, we want to make sure that it has good voltage. Woo. There we go. Yeah. Yep, there we go. Get that melt in there a little bit. There we go. Yeah, big ground plane. Yep, there she goes. Yeah, there we go. I like that. All right. Yep, there we go. We'll hit it again. On this guy. All right. Okay, where is... Let me look at that 12 volt regular. Where's that 12 volt bridge rectifier? Right here. Let's look at the back side of him. That's that was next to the fuse blocks that we already got. So let's get that rectifier. And I think gonna be good. That or we'll burn it out. One of the two. We'll see. Okay. Good stuff. So we got some reflow action. Have to look at this under the scope, make sure it's all okay. Then we've got the fuse holders, the bridge rectifier, test points. And then I think the rest of the ICs look pretty good. Didn't see any damaged stuff, so. All right, let me cut here. Let's get this thing reassembled, ready to hook up. So okay, so we're back after doing some troubleshooting on the soundboard. And I think I'm onto something. I think I'm actually onto something I was on the last time I had this on the bench. So let's go ahead and walk through kind of the steps of your soundboard. If you're ever on a D8224, there's just like some basic steps being power. Hang on, I'm getting ahead of myself. So I powered up after the new capacitors, and the power looks wonderful. The power looks really good. We can go through some of the voltages later. The voltage regulator, the 12 volt, is much closer than it was. Well, anyway, still no sound. So right now we're in test mode 4, which is the sound test. So in sound tests, we should have our analog signals coming in 2 through 8. And I believe 8 is used for speech only. So we could probe on all of those, and you would see that we have activity on them. I won't take you through all 7. We got 2 through 7 all have activity. Okay, let's go to the print. Okay, so coming in, what these are your sound speech select input bits. And I checked out this network array, and actually a couple of these look shoddy. I almost changed him, but I found something more shoddy on this IC5. Okay, so all your signals come in, and then I think they come in, and these are pulled high, so these are going to ground them. You're going to get grounded and send a signal to this IC5, which is just a CMOS buffer, pretty much. So all these signals come in, and this one here, number 4, he is stuck low. So let's go over to number IC5. So let's probe on him. Okay, so we have our input, and we can see he has activity. Okay, so I've got this set up. I've got a new 4050 with a jumper. So let's check out the top chip. So the top chip output, pin 4, is not grounded. So he has activity. But let's look at the original chip. Let's probe under there. Let's probe on the chip itself in question. He is stuck low. So what's happening, in turn, he is pulling this leg low on this TC4068, which is weird. It's an 8 input NAND and gate. So basically, let's look at that chip, and then you'll see what's happening. So this is a 8 input NAND gate. So pretty much all of these have to be high for the output to go low. And any of these low will cause this guy to stay high. Well, the output for this guy feeds into the PIA. So this guy is never going low. There is no activity on this guy because of this guy. So let's check it out on the schematic. Let's see, find my cursor. Okay, so this guy here, let me find my cursor. He is stuck low. So if we look at this 4068, it's an 8 input. It's actually an AND NAND gate. This is the NAND output, and pin 1 is actually the complement of the NAND, which is an AND. But they're not using it on this chip. It's not connected. They're only using the NAND output. And then he goes up to the PIA CB1. I got to look that up. I'm not sure what the CB1 is, but it does want it to go low. This line's got to go low for some reason. I'm not sure that's why we don't have any sound, but we're gonna go from there. We're gonna swap out. We're gonna swap out this 4050 here, because that gate is he's definitely stuck low. There's the good one. Has activity. Let's go to the bad one. He is stuck low. Now, if I bend that down and touch it, and touch that leg, if we give it like a proper jump, it is pulled down, so it's shorted so badly. I'll show you what's happening. It's shorted so badly it won't let it come up high at all. So let's probe back on it with it. See it trying to go high. It's shorted so bad it can't go high. All right, so that was the initial round of troubleshooting. So check all of these for activity. You check your resistance, 4.7K. There's some weird ones, but this is in circuit. It's always hard to tell. There's mostly good ones. Then you need to check your resistors here, make sure that they're in value, and you need to check your capacitors, make sure that none of them are open. And then after that, you can start following these signals through to these buffers and inverters or whatever before it gets to the PIA. So let's get the solder gun out. Let's get that chip off.
Okay, so
got
the socket in,
and we'll be
got
back
the
in
other
a
chip
minute.
out. Got the socket in, and kind of comparing this, looking at the CMOS buffer in the retro chip tester. Had to find an equivalent test. It will not run on a 4050, which is also a buffer, but it will run on an equivalent 4050. So let's run that guy. Yep, fail. And I kind of know that we're in good shape because I've got I got another one here. I have a new one. So the new one passes. It's also a 4050, but it will pass here. And also if I put it in the Chinese one, yeah, this guy's actually good for some stuff, to be honest, but I still don't trust it. Alright, it just failed boot because I have a chip in it, but actually, let's see. It just fired right up last time. Alright. Let's let it start up, do it self-test. Okay, so unless I got that locked in the backwards. Yeah, mate. Nope, I think that's the right way. Let's get that guy in there. And he comes up a 4010, 4050. I could take you through, but this one passes in there and the old one does not. So that is the 4050, correct? All right, we're gonna power this thing on for the first time. I don't know if we got sound, that would be freaking great, but I'm not gonna hold my breath. All right, let's get that dude in there. All right, got the new buffer. Power on. We'll see. Got the speaker right here. We're turned up. I think I heard a little. I think I heard something come out of there. No coin action. Nope, no coin action. Let's check. What I really want to check first is that buffer leg. Here's the one that was. Well, actually, let's start a game since we're here. No, nothing. All right, let's go into test mode. Let's go to sound test. Let's just let it roll. Okay. So now we're just scrolling through the sounds. Let's check that stuck gate. There is indeed activity there now. Good stuff. So let's follow it over to its input on that quad NAND gate, sorry. So the input is good on the NAND gate. Let's check the output. All right. So now we have the correct signal going to the CB1 on the PIA. All right, and he is definitely toggling. Still no sound. Okay. Well, we're working our way through. Let's hit the diagnostic sound. Man, that thing is so hit and miss.
whether there's sound or not. All right. Okay, well, that's one obstacle out of the way. That is one obstacle out of the way. All right, I'm going to cut, do some more troubleshooting. I think I'm just going to follow these through. You know, the PIAs are known to go bad in these. I may throw in another 6808 because I can't verify that this one is good. Maybe that's the next step. Maybe I'll go grab the other one. And we're back. Throw the other one in and see what's up. We have sound. And we have sound. Yeah. So, here in sunny Thailand, my allergies are kicking my butt, so I medicated. I took some congestion medicine, man, and it put me out. Blah, whatever. So, in between my delirium, was able to get some movement on this board. Okay, so we have sound. So let's, I'm going to walk you guys through what's happened since the last video. Let's cut this. I have my amplifier circuit in right now because I am getting sound through my test box, but it's so low you can't really hear it. So it's still coming through. It's so low you can't hear. Anyway, okay, so the last we left, we were dealing with this. We replaced the 4050 here, had a stuck gate, and it was feeding this 4068 CMOS. It's like an 8-input NAND gate. So if all our, let's see, these all have to be high, or any low will force a high, basically, for the output. So I think that's where we were last time. That's right where we left off. So that was definitely a problem. And we had no sound still. And everything's in hindsight, right? So since the last video, I socketed the PIA. I swapped out a new 6808. New PIA, still no sound. And in hindsight, I should have been onto it. The data lines, when I probed on the data lines for the PIA, the data lines here, they were like in bursts. They were bursts of data, and it didn't look right to me. And they were kind of, they weren't triggering right. They were between like 3 volts and 4.5 volts, like the spikes, the signals. And it's hard to tell with data lines. I've seen goofy data lines where some of them are in bursts or whatever. But so the problem was, we'll cut right to the chase. The problem was this RAM. The RAM was bad. It was the 6810 RAM was bad. So I've got it chucked up into Retro Chip Tester, and it won't even read. Yeah, it's so bad, it won't even read. So, working off of, let's see, I'll show you guys. And my friend or buddy, I don't know if we're friends, but he tolerates me enough to ask him some questions. Brad, the Williams guru, reminded me that I can use a 6802 and enable the RAM sector of that CPU. There's a quick little mod, like under this resistor. What is that resistor? 34, 35, something like that. Underneath this resistor, you cut the trace, and then that will enable the 128 by 128 by 8K RAM on board this 6802. So I went ahead and did that. I have some 6802s. So I did that. I left the RAM out. Sometimes if you leave them in, I guess there's a problem. It'll stick a line low, and then it will kind of jack things up. But now that I did that, boom, I had sound. So let's go back to the schematic here. And I'm going to show you guys. I watched some videos and some forums on this. Let's see. Data lines, 33 to 26 on the PIA. 33, oh, 30, oh, yeah, 33. You see 49, 8, 7, 6, 5, 4, 3. All right. See those data lines? That's how the data should look. If you're getting bursts, and let's just work our way through. That's data line 0 and 1 and 2. If you're getting bursts, if you check your data lines and you're getting burst of activity, I think that's a good indicator that your RAM is bad. And I checked these before. I don't have them on film, but they were just bursts. They were just short times of bursts, and that was the problem. So in hindsight, and okay, so the videos I watched were interesting because people complaining about the same problem were stating that their diagnostic switch was intermittent, just like this one. So I think it mattered like when you hit the switch versus where the data was writing at the moment, whether it would take the input of that switch. So if you have intermittent issue, I would go right for that RAM out of everything I've seen and kind of learned on this. So what else did I do? Don't be like me. I did shotgun this 4068. I figured if that one was bad, maybe that chip was still bad. So I got him out and I checked him in the chip tester, and he was fine. I hate shotgunning, but whatever. And I did also check out this DAC. And actually, I just kind of wanted to isolate. My idea was to isolate some of those data. So it was weird. You do on this DAC, you do have, let me show you. You do have address lines on this DAC on 5, 6, and 7. And why I pulled him, 5, 6, and 7 was dead on this DAC. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And changing that ROM out brought back the data or the addressing. So this side was completely dead. 5, 6, and 7 was completely flat, and then 8, 9, 10, 11. All the addressing over here was okay. So something to do with that data. Those data bursts weren't letting the address get to the right locations. So that's why I pulled this guy. 5, 6, and 7 had no data, no activity. I go, oh, maybe the DAC is bad. No, the DAC was okay, actually. What else did I do? I did put a new transistor at Q2 in, because that feeds your final mixed sound out to your speaker. So I was like thinking, okay, maybe between there and your speaker, maybe there's a problem. But I don't mind changing transistors. But he's good to go. We're good to go. What else did I want to show you guys? I think that's about it. So yeah, just in summary, swapped him out with the 6802. Cut the trace under this guy. This resistor enables the RAM. You don't need a 6810 anymore. It'll use the RAM that's built into the CPU. And yeah, nice little mod. So I went through this thing for a day or two, checked all my jumpers, all my input signals here. Number 8, don't worry about number 8. He's going to be dead all the time. I think that's for like a sound enabled or a handshake on a speech enabled game. I did put a new amplifier in, because I got a bunch of those anyway. So I put a new amplifier in, new caps, cleaned the fuses. The voltage was okay, so I didn't do anything with the 5 the 5-volt regulator. Just left him. So I think we're good to go. Let's turn this back on. Get the sound going again. Oh, my. Yeah, so I have him clipped on the preamp output. There we go. So let's get out of here and start a game. Okay. Have coin. Have start action. Yeah, I'm not going to be able to play very good. Skid mark. Let's see if we can get at least one. Boom. Alright, we got one. Just going vertical. Yeah, it's such a cool game. I love this game now. I actually got pretty good at it. Can't wait to play it with real controls. Oh, I thought I was going to get one there. Boom. Okay. There's another issue with this board set. So if I play for a while, I am seeing some artifacting down here, and the game occasionally resets. Now I've worked completely out of order on this board. Usually I would just change all the sockets, the RAM sockets, the decoder sockets, all the CPU. Same with the ROM board. And I think that's where some of the reset issues, because I haven't even reset these. Like after I finish the video, I'm going to go ahead and dump these. And the next, there it comes. Ooh, yeah. So I'm going to go ahead and dump these guys. The decoder, I already dumped the sound ROM. I think that's going to call it good on this video. The next time we see this board, it will be for resocketing and long burn play. Make sure that the reset's not happening anymore. But the game is running. And like I said in my last video, this is going to be my last repair here because I'm rotating back home. That's another reason I'm not going to do these now. I'm ready to get the lab packed up and get everything shipped home. So at least I know where I am on this one, and I got to make one more video, the promised Joust video for my friend Adam. So, Adam, if you actually watched this long in the video, this one was for you, buddy. So, okay, thanks for everybody's help. Brad, everybody who's posted videos, Jack Lick, Classic Arcade Repair, Sean, I love your videos. In the forums I read, again, about this intermittent sound, I believe derives. A lot of people use the Logic Pro, but if you get on there with an O-scope on your data lines, at least that's where I would say your data lines look funky. Check that RAM, get it out of there, go with the 6802, fix you up. So, okay, guys, that's gonna wrap it up. I don't think I have anything more to add. I don't have anything more to add. So thanks, guys. I hope you like these videos. You can maybe give me a like and subscribe. Yeah, I'm all allergied out and stuff. So this is Elder Rock signing off from my lab here in Thailand. I'm going to miss this place, but the real lab's going to be kick-ass. Just wait till we get home to the real lab. It's going to be effing awesome. Okay, see you guys.